In this video, we're going to talk about solving systems of equations by graphing with linear and quadratic equations, so a mixture of a line and a parabola or two parabolas. So in our first example, we have a line, x plus y equals 4, and a parabola, y equals negative x squared plus 2x plus 4. So first thing we're going to do is graph them, and then to find our solution, we're going to figure out where these two graphs intersect each other. So for our first equation, we have x plus y equals 4. We need to get this in a form we can graph it, so we're going to move x to the other side so that we get y equals 4 minus x, which means we have a y-intercept of 4 and a slope of negative 1. So we'll move down one left, or down one right one, or up one left one for our line, and then we'll just draw our line through all of those points. And make sure you're plotting those points and not just sketching that line. If we're looking for the point where they intersect, we have to see some actual points. All right, for our parabola, y is already by itself. We're not going to have to solve for that. This equation is in standard form, which means we already know the y-intercept. It's going to be at 4. So we can plot that. Next thing we want to know is the vertex. So to find the vertex of our parabola, we can use the formula negative b over 2a, which will be negative 2 divided by 2 times negative 1, where this is our a and this is our b. So that gives us negative 2 divided by negative 2, which is just 1. Then to find our y value, we'll take that 1 and we'll plug it back in for all the x's in our equation. And this will give us the y value of our vertex. Let me fix this right here. Y equals all that. All right, so following our PEMDAS steps, we're going to square that 1 first and then apply the negative. So that's going to give us negative 1. 2 times 1 is 2 plus 4. 4 plus 2 gives us 6, so negative 1 plus 6 is 5. So that gives us that our vertex is at the point 1, 5. So we can go ahead and plot that. And we know that all points on a parabola are reflective over the vertex. So if we already have our y-intercept plotted, we can just reflect that over the vertex. So if it's 1 unit away from the vertex, we can move 1 unit the other direction and plot that point. And then let's find one more point that we can also reflect over. We can choose that x value. It doesn't matter what x value you choose. I like to keep expanding along the x-axis. So if I've got a point at 0 and 2, my next options would be 3 and negative 1. So let's plug in 3, and we'll do the same thing we did when we plugged in the 1 earlier. Let's just make that smaller. So we'll have y equals negative 3 squared plus 2 times 3 plus 4. So we'll square 3 to get 9, then apply the negative to get negative 9. 2 times 3 is 6 plus 4. 6 plus 4 is 10, minus 9 gives us a 1. So that means we have another point at 3, 1. And that we can also reflect over. So that's 2 units away from our vertex. So if we go 2 units the other direction, we can get another point there. So that'll give us our parabola. And then remember, our answer is where these two graphs intersect each other. So we have an intersection here at the y-intercept and then another at the point 3, 1. So we're going to list both of those as our answer. So we've got 0, 4 and 3, 1. So with parabolas, it takes a little bit more work because we do have to find multiple points and we can't just move using a slope, but our end goal is still the same. We're still looking for where these two lines intersect each other.